Now that we've defined probability and conditional probability, we can start talking about some rules that allow us to calculate more complicated probabilities. The addition rule for probability is an immediate consequence of the addition rule for counting. The idea is the same. You add the individual probabilities and then subtract the overlap. So if E and F are subsets of omega, then the probability of E or F, read as E union F when we're talking about sets, is equal to the probability of E plus the probability of F minus the probability of both E and F. The multiplication rule is pretty close to what we'd expect, but we have to account for the fact that if F occurs, then that might make E more or less likely. So we're going to let E and F be subsets of omega. Then the probability of E and F is equal to the probability that F occurs, then multiplied by the probability of E given that F occurs. Remember, we have to pay attention to whether or not F affects the probability of E. Since E and F can be written as F and E, the right-hand side of that equality could have just as easily been P of E times P of F given E. It doesn't matter which we put as long as we multiply by the given event. Let's do a few examples. Suppose that someone takes a study of some students, this is totally made up, and determines that 52% of students drink energy drinks and 29% of students get their daily servings of vegetables. Of the students that eat their vegetables, only 5% drink energy drinks. So a really good way to start whenever we have a question like this is to write down the given probabilities in the correct notation. So we're going to let the letter E stand for the event that a student drinks energy drinks. And we're going to let V stand for the event that a student eats their vegetables. Then we are told that the probability of E is 52%. We are told that the probability of V is 29%. And the one that's a little trickier to read is the last one. Of the students who eat their vegetables, well, that tells us that eating vegetables is the given event. All right, so the probability that someone drinks energy drinks given that they eat their vegetables is only 0.05. So the question asks, what is the probability that a student drinks energy drinks and eats their vegetables? So that's the probability of E and V, which is, I have a choice here. Because the one I know has V as a given event, I'm going to do P of V times P of E given V. So that's going to be 0.29. 29% of my students eat their vegetables times 5% of those students drink energy drinks. So the probability that somebody does both is 0.0145. What is the probability that a student drinks energy drinks or eats their vegetables? So let's remember what we just wrote down. We just wrote down that P of E and V is 0.0145. So when we see the word or here, we know we're going to use the addition rule. P of E or V equals P of E plus P of V minus P of E and V. So we just substitute the values that we know. Probability of E is 0.52. Probability of V is 0.29. And the probability of both is 0.0145. Add all those together and subtract the overlap, and you get 0.7955. Maybe we'd also like to know, what is the probability that a student who drinks energy drinks gets their vegetables? So remember that the given probability is that P of E given V is 0.05. We're asking, what is P of V given E? All right, they're not going to be the same. So the formula is the probability of E and V divided by the probability of the given event, which is P of E. So that's 0.0145 divided by 0.52, which is 0.0279.